Hello everyone. We're going to continue our lesson now. So we're done with chapter 2, no? So we now proceed with chapter 3. So this is the last slide, no? I have presented. So let's now move on with our next topic. So we're now on chapter 3, polynomial approximations and interpolations. No? Okay, description of this chapter. This chapter deals with finite differences of a function, approximating function of an actual function, and interpolations. So in this case, the objectives are as follows. Okay, you are expected no, to determine the finite differences of a function. Okay, and then you are to solve the approximating function of an actual function and also apply the interpolation formulas in this module to determine approximated values of actual functions. So this is our first topic on chapter 3, divided differences of a function. no? So in this case, we let y equals to f of x no, be a function given in tabular form for a sequence of distinct values of x. So we have here sequence of distinct values of x. We have x sub o, x sub 1, x sub 2, x sub 3, and so forth. Then we have the functional values. No? We have f of x sub o, f of x sub 1, f of x sub 2, f of x sub 3. Okay? Now, our function is given in tabular form. Okay? And in this case, note that x sub 0, x sub 1, x sub 2, and x sub 3, and so forth are called arguments. So we call these as arguments, no? X sub 0, x sub 1, x sub 2, x sub 3, and so forth. Then we have here first order divided differences of a function, f of x. So how do we get the first divided differences of f, or first order divided differences of f of x? No? So we use the formula. So we have f of x sub I, x sub j equals to f of x sub I minus f of x sub j all over x sub I minus x sub j. So in here, let's say we begin with I0 followed by j1. No? So for example, if I0 and j is 1, so this will now be the formula. F of x0 minus f of x sub 1 all over x sub 0 minus x sub 1. This will be the formula. No? And this is now the first order divided differences of f, considering x sub 0 and x sub 1. Okay? The first order divided differences of f. Okay? Now, likewise, if for instance, if I is 1 and j is 2, okay, so we have f of x sub 2 minus f of, what should I say, f of x sub 1, okay, f of x sub 1 minus f of x sub 2, okay, f of x sub j over x sub 1 minus x sub 2. So this is the formula. Okay. Okay, so we now proceed. So this is the way on how to find first order divided differences of f. Okay. So we have the first order divided differences of f of x sub 0, x sub 1, f of x sub 1, x sub 2, f of x sub 2, x sub 3. So these are called first order divided differences of f. Okay, and so forth. Okay, now we proceed. So we have here the second order divided differences of f of x is given by the formula. So this is a formula for the second, finding the second order divided differences of the function. Okay, so for instance, I have an example. So we have x sub 0, x sub 1, x sub 2. Okay, and in this case, the formula is simply f of x sub 0, x sub 1 minus f of x sub 1, x sub 2, okay, over x sub 0 minus x sub 2. So this is the manner on how to solve it. No? For the second order divided difference of f, okay, considering x sub o, x sub 1, and x sub 2. Okay, likewise, for instance, I have x sub 1, x sub 2, x sub 3. Okay, this will become x sub I, x sub j, that is x sub 1, x sub 2. Okay, then followed by x sub j, x sub k, that is x sub 2, x sub 3, x sub 2, x sub 3, all over x sub I minus x sub k, x sub 1 minus x sub 3, x sub 1 minus x sub 3. Okay, and we call these two, okay, as second order divided differences of f. Okay, so and this will continue. No, we have f of x sub 2, x sub 3, x sub 4, x sub 4, x sub 5, x sub 6, and so forth. No? So those are the second order divided differences of f. Okay, so we now proceed. So where x sub j is the common argument. No? So we have here x sub j. This is the common argument for the two functional values. For the two functional values f x sub I, x sub j, and x sub j, x sub k. No? So for the two first order divided differences of f. Okay? So x sub I, x sub j, x sub j, x sub k. So the common argument is x sub j. Okay? And then we have here x sub I and x sub k. Okay? So x sub I and x sub k are the arguments not common for the two first order divided differences of f. No? So the two f of x sub I, x sub j, and f of x sub j, x sub k. So then we have So this is the general rule. The nth or nth order divided differences of the function is given by the formula. So this is the formula in finding the nth or the nth order divided differences of the function. Okay. So for example, if I have x sub 0, x sub 1, x sub 2, x sub 3. So this is the third order, no? So this is n, so n is 3. If n is 3, we have the third order divide the differences of f. Okay, then this will become f of x sub 0, okay, x sub 0, x sub 1, okay, until we reach x sub 3 minus 1. So that is x sub 2, okay, minus f of x sub 1, x sub 2, until we reach n equals 3. So we have x sub 3 all over x sub 0 minus x sub 3. Okay, so that's it. No? So as you notice, we have the common arguments x sub 1, x sub 2. Okay, we have the common arguments x sub 1, x sub 2. So x sub 0 and x sub 3 are not common to the two second order divided differences. Okay, so we can proceed. So we have x sub 1, x sub 2, x sub n minus 1. These are the common arguments for the two divided differences. Okay, so and then x sub 0 and x sub n are the arguments not common for the two divided differences. Okay, now divided differences of all orders are symmetric functions of their arguments. In other words, this is the interpretation of the statement. Divided differences of all orders are symmetric functions of their arguments, regardless of the position of the arguments inside the function. No? So regardless of the position, let's say the order is x sub I, x sub j, x sub k, or the order here is x sub I, x sub k, x sub j, or x sub j, x sub I, x sub k, it doesn't matter. Okay? They are equal. Okay? They are all equal. Okay? So the value will just be the same, no? For the divided differences. So that is the reason why is it. So this is the interpretation of the statement. Divided differences of all orders. Second order, third order, first order, fourth order, and so forth. They are symmetric functions of their arguments. Okay? Now, the divided differences of a function can be displayed by constructing a difference table. So we can able to construct a difference table for divided differences of a function. Example of a difference table for divided differences of a function, we have this one. So we have x, okay, followed by f of x, followed by f of x sub I, x sub j, first order divided differences of f, second order divided differences of f, third order divided differences of f. Okay? So that's it. No? So we now proceed. So we have here a specific numerical example of a difference table for divided differences of a function f of x. Alright, so in here we have an example. So let's apply the formula. So how did we arrive with these values? So how did we arrive with these values? Okay, we just apply the formula for it for divided differences. Now, so let's try. How did we get one? No. So by formula, okay, f of xi x sub j. Okay, that is the formula for the first order divided differences of the function. That is f of x sub I minus f of x sub j over x sub I minus x sub j. Okay, so in that case, f of this is x sub 0. This is x sub 1. This is f of x sub 0. This is f of x sub 1. This is f of x sub 0, x sub 1. Okay, this is f of x sub 0, I is 1, I is 0, okay, and j is 1 here. Okay, so in that case, if I is 0 and j is 1, f of x 0, x 1, that is f of x sub 0 minus f of x sub 1 over x sub 0 minus x sub 1. If we solve that, so we have f of x sub 0 is 0 minus 1 over x sub 0 is 0 minus x sub 1 is 1. We get 1. That's why we get 1. Okay, so another example, let's try 8. How did we get 8? Okay, how did we get 8? How did we get 8? So what is 8 here? This is f of what? So this is x sub 1, x sub 0, x sub 2, x sub 3. Okay, so as you notice, 8 here has a relation, has something to do with 13 and 37, has something to do with 1 and 64, and it has something to do with x sub 3 and x sub 1. Okay, so meaning I now is 1. We start with 1. Okay, so that is f of x sub 1 followed by x sub j, that is x sub 2, followed by x sub k, that is x sub 3. Okay, so that is now 8. So let's in this case, this is f of, it has something to do with 1 and 27, right? 13 has something to do with 1 and 27, so that is x sub 1 and x sub 2. So this is f of x sub 1, x sub 2. Okay, and then uh, 37 has something to do with x sub 2 and x sub 3. Okay, x sub 2 and x sub 3. So this is f of x sub 2, f of x sub 3. So f of x sub 1, x sub 2, x sub 3. Okay, so by formula, this is f of Okay, let's recall, no? F of x sub I, x sub j, x sub k, that is f of x sub I, x sub j, minus f of x sub j, x sub k, all over x sub I minus x sub k. So we substitute. We begin with I equals 1. So this is for I, this is for j, and this is for k. So we begin with x sub 1 followed by x sub 2, x sub 1, x sub 2, followed by jk 2, 3. So x sub 2, x sub 3 over x sub I, that is x sub 1 minus x sub k, x sub 3. Okay, so we have, so what is f of x1, x2? So that is 13. That's 13 minus f of x2, x3, that is 37 over x1 minus x3, that is 1 minus 4. 1 minus 4. So what is 13 minus 37? That's about 4, negative 24, I think. Negative 24, okay, over negative 3. So what is 24 over negative 3? So 24 over negative 3 is 8. That's why we get 8. So the value of f of x1, x2, x3, which is the second order divided differences of f, considering x sub 1, x sub 2, and x sub 3, that is 8. Okay? So let's try one more. Let's try how did we arrive with 1? So we consider this one. We consider this one and this one. We consider this one and this one. And last, this one. Okay? Therefore, it has something to do with, this is now a function of, uh, this is x sub 0, x sub 1. So this is x sub 2, x sub 3, x sub 4, and x sub 5. Okay? So this is x sub 2. So we have 3 and 9. Okay? So we have f of x sub 2, x sub 3, x sub 4, and x sub 5. Okay? And by formula, no? So f of x sub I, x sub j, x sub k, x sub l, ij, k, l, third order divided differences. Okay? That is f of x sub I, x sub j, x sub k, minus f of x sub j, x sub k, x sub l. Okay? Over x sub I minus x sub l. Okay, let's apply. So let's apply. We have Okay, I'll repeat. F of x sub j, x sub k, x sub l. Ah, over x sub I minus x sub l. Okay? Oh, sorry. So we have, so this is now equal to f of x sub 2, x sub 3, x sub 4 minus f of x sub 3, x sub 4, x sub 5. That's it, over x sub 2 minus x sub 5. Okay? So we have, so this is f of x sub 2, x sub 3, x sub 4. This is f of x sub 3, x sub 3, x sub 4, x sub 5. Okay? So we have 14 minus 20. Then x sub 2 minus x sub 5, 3 minus 9. We have 3 minus 9. Okay? 14 minus 20 is negative 6, right? 14 minus 20 is negative 6 over negative 6. That is 1. That's why we get 1. Okay? That's it. So we now proceed. So here's the problem. So construct the difference table for divided differences of the function. Okay. So let's answer this. So we have the table, no, column for x and column for f of x. Okay, the values of x and f of x. So take note that in order to construct the table, so we let the lowest value of x be x sub 0, okay, until we reach the highest value of x, which is 7. So that is x sub 4. Okay, and then we have this consideration now. Now we have using okay, given this, we can proceed with our solution. So we have x sub o, x sub 1, x sub 2, x sub 3, x sub 4, f of x, f of x o, f of x1, f of x2, f of x3, f of x4. So as you notice, until x sub 4 only. Okay, we are to construct the difference table until we reach x sub 4. Okay, so that's why, so these are the first order divided differences of f, second order divided differences of f, third order divided differences of f, and the fourth order divided difference of f. Okay, so we consider that, and in considering that, so to get f of xo x1, so it's simply f of xo minus f of x1, right, over xo minus x1. That's it. Then we get it. We get this, no? For Another example, if we are to get this one, f of x sub 0, x sub 1, x sub 2, x sub 3. So that is simply, so this one, f of x sub 0, x sub 1, x sub 2, minus f of this one, x sub 1, x sub 2, x sub 3, all over, okay, this starts with 0, right? So we have x sub 0, this ends with x sub 3, right? So we have until reaching that, so this ends with x sub 3, so minus x sub 3, okay? So then we will get the value, no? And so forth, no? So let's doing that, no? So we know this, we apply this, no? Okay, so knowing this, so we can replace x sub 0 by x sub 1 and so forth, no? So it's just the same, no? If we start with x sub 1, so this is replaced by x sub 1, x sub 0, no? So then we have, so we can able to replace 1 by k. We can replace 1 by k. So we have x sub k, x sub k plus 1, x sub n, and so forth, no? So just a variation of the formula, but still the same. We will arrive with the same answer, no? So considering that, no, applying the formula, so this minus this all over 4 minus 4.5, no? 1.58740 minus 1.65096 all over 4 minus 4.5, we get this one, okay? Then 1.65096 minus 1.76517 over 4.5 minus 5.5, we get this one. So using Excel, it's we can simply know the answer, right? So you can use Microsoft Excel to do the math, no? And so forth and so on. How about this? How did we arrive with this answer? Simply that is 0.12712 minus 0.11421 all over 4 minus 5.5. Okay, that's it. Okay, so you know it, no need to elaborate. So about this, so that is negative 0.00687 minus negative 0.00539 over, so over what, 4.5 minus 7, okay? So that's it. So then we get 0.0059, 0.00059. Then the last, the fourth order divided differences, we have negative 0.00009. Okay, so that is simply 0.0087 minus 0.0059 all over 4 minus 7. Then we get this answer. Okay, I hope you get it. So now let's now study this topic, differences of a function, using the advancing difference operator. So we're done with divided differences of a function. This time, differences of a function is what we will talk about. So in here we have forward difference table, or we can say it also as advancing difference table. So this is the forward or advancing difference table. In my previous slide, no, that is the divided difference divided differences table, no, divided differences table. Okay, now this time it's the forward advancing difference table. So for the forward advancing difference table, okay, so we have this row is to be considered, no, the topmost row. So we have delta f sub k. So we have x sub k, f of x, f of f sub k, delta f sub k, delta squared f sub k, delta cube f sub k. Okay, so these are important, so for us to construct the forward or advancing difference table. So there's a formula on how to arrive with these values. No? Okay, take a look at its property. For its property, uh, we have age, which is the difference between the two consecutive values of x. No? So we have x sub 1 and x sub 0, their differences. So we have the successive value of x minus the preceding value of x sub 1 minus x sub o. So the interval is age. So there's an interval of age. Between x sub 1 and x sub 2, there's also an interval of age. Okay? So that's why we have the x2 minus x1 is age. Okay? Between x2 and x3, there's also an interval of age. Okay? That is the characteristic of the table. No? So the gap between x sub 0, x sub 1, x sub 1, x sub 2, x sub 2, x sub 3 is uniform. No? So so the interval is uniform between consecutive values of x. Okay? So in general, x sub k plus 1 minus x sub k is equals to h. No? So we have the successive value of x minus the preceding value of x. We have the interval h. Okay? Now we proceed. So knowing that, so since h is now equal to x sub k plus 1 minus x sub k, we can rewrite in terms of x sub k and h. So we have h plus x sub k is equal to x sub k plus 1, right? So we have this h plus x sub k equals to x sub k plus 1, this which is the same as this. Okay, so knowing that, we have here, if k is 0, what will happen? If k is 0, we have x sub 1, so x sub 0 plus h, no? And then If k is 1, okay, for k equals 0, for k equals to 0, for k equals to 1, we have x sub 2 equals x sub 1 plus h. Now, from the first equation, okay, from the first equation, we have x sub 1 can be replaced by x sub 0 plus h. No? So this is now the replacement. Okay. So we replace x sub 1 by x sub o plus h. And we simplify, that is x sub 2 equals to x sub o plus 2h. Okay. And there's a pattern now. Okay. We see a pattern. This is 2 and this is 2. No? So there's a pattern. Therefore, we know that this is for k equals to 2, right? For k is equals to 2. X sub 2 is equals to, or should I say, for k equals to 1, x sub 2 equals x sub o plus h plus h. So that is x sub 2 equals xo plus 2h. No? So in that case, this is, we know that this is x sub k plus 1, right? Equal now to x sub o plus, so 2 and 2. So if this is k plus 1, this is also k plus 1. K plus 1 each, right? Or simply, we can we can uh, we can able to convert k plus 1 in terms of k alone. So this will now be simplified as x sub k is equals to x sub o plus kh. Okay, we can get rid of k plus 1. We can simply write it as k. Okay, in general, no? So x sub k equals to x sub o plus kh. So if k is 0, so we have x sub 0 equals to x sub 0 plus 0h. That is cancelled. So x sub 0 equals x sub 0. If k is 1, so x sub 1 is equals to x sub 0 plus 1h, or simply h. Right? The interval is h, right? xo plus h is x sub 1. Likewise, the interval here is h. So x sub 2, um, for k equals to 2, x sub 2 equals x sub o plus 2h. So that's right. X sub 2 is simply x sub o plus h plus h. So that is x sub o plus 2h. Okay? I hope you get it. So this will now be the interpretation. X sub k is now equal to x sub o plus kh. So knowing that, this is the notation for the first difference, first differences of the function. First differences of a function. Okay? Delta, denoting first difference of a function. No? So the first differences of f, okay, can be obtained by subtracting the preceding number, or should I say the preceding value of f, no, from the successive value of f. That is fk plus 1. Okay, so delta fk, so this is the first differences of a function. Okay, in obtaining the first differences of this function, simply the uh, subtract the preceding functional value from the successive functional value of f. Okay, that's it. Or simply, delta f sub k now is equal to successive functional value of f minus preceding functional value of f. Okay, so fk plus 1 minus f sub k. So to give you an example, okay, let's consider for k equals to 0, okay, for k equals 0, we have delta f sub o, we have f sub 0 plus 1 is 1, k is 0, f1 minus f0, okay, that is f1 minus f0. So in that case, this is delta fo, that is simply f1 minus f0. Simply as that. No? That is the manner on how to get the first difference, the first differences of a function for k equals to 0. Okay, so take note that these are the first differences of the function: delta f sub o, delta f sub 1, delta f sub 2. No, the first differences of a function. Then these are the second differences of the function: delta squared f sub o, delta squared f sub 1, and so forth. Then we have also the third differences of a function: delta cube f sub o, and so forth. Okay, and this is what we call as the advancing difference operator. No, so this is the triangle. It's what we call as the advancing difference operator. Okay, or it can also be called as the forward difference operator. Okay, forward difference operator, or advancing difference operator. Okay, so we proceed. Next, we are to obtain the second the second differences of the function, denoted by delta squared f sub k. Okay, so delta squared f sub k, how do we get delta squared f sub k? So we can able to uh, rewrite delta squared in terms of this. It is a property of the operator. We can separate, no, delta delta, delta squared, right? Delta delta is delta squared. Delta delta f sub k. So delta of delta f sub k, that is simply delta f sub k plus 1 minus delta f sub k. No? So the successive value minus the preceding value. Okay? Successive value minus the preceding value. So in order to determine the second differences of f. So this is our goal, to obtain delta squared f sub o, delta squared f sub 1, and so forth. Now, if, for instance, I'm interested in finding delta squared f sub 1, that is simply delta f If k is 1, that is f sub delta f sub 2 minus delta f sub 1. Okay? So I will subtract the preceding value from the successive value of the first differences of f. Okay? So I will subtract the preceding value from the successive value. So that is delta f2 minus delta f1. Okay? In order to get the second differences of the function for k equals to 1. Okay? And now we proceed. So in general, uh, the n differences of the function f sub of the function f, no, the n differences of the function can be obtained by considering this, okay, which is a property of the operator. So we can rewrite it in terms of this. We have delta n minus 1. So applying laws of exponents, what is delta multiplied by delta n minus 1? That is delta to the power of n, right? Because this is 1. If I have a to the m times a to the n, that is simply m plus n, right? So I simply add 1 and n minus 1, I'll get n. Okay? So we have here delta n minus 1 f sub k plus 1 minus delta n minus 1 f sub k. Okay? So this is the n minus 1 n minus 1 divided differences of f successive minus n minus 1 divided differences of f preceding. Okay? So this is successive value minus the preceding value. Okay? You'll get the n differences of the function. So usually the values of x in a table of data are equally spaced. No? So which is a property of the advancing difference table or the forward difference table. No? The values of x in the table are in the table of data are equally spaced. Now that's why the interval h is uniform. Now, given this situation, any value of x in a table of data can be obtained using the formula. Okay, so this is in my previous discussion. K x sub k equals to x sub 0 plus kh. No, I have already derived this formula. Okay, so we're in k is any integer. No, k is any integer. It can be negative integer, it can be 0, or it can also be a positive integer. Okay, and the corresponding functional value of is this one. Okay, so take note. Okay, in the table I have shown in the previous slide, f sub k is interpreted as f of x sub k. Okay, so that's the interpretation. F sub k is interpreted as f of x sub k, or simply y sub k. Okay, and since x sub k is xo plus kh, no, we can replace x sub k here by x sub o plus kh. It's just the same as this one. Okay, so we proceed. So note that the first differences of f are defined by the formula. So this is the formula. Okay, delta f sub k equals to f sub k plus 1 minus f sub k. The second differences of f are defined by the formula. Delta squared f sub k equals to delta of delta f sub k equals to delta f sub k plus 1 minus delta f sub k. In general, the nth differences of f are defined by the formula delta to the power of n f sub k equals to times delta to the power of n minus 1 f sub k equals delta to the power of n minus 1 f sub k plus 1 minus delta to the power of n minus 1 f sub k. Okay, so that's the general formula, no, in finding the n differences of the function. And take note that delta here is, so we have the Greek letter delta, no? Greek letter delta. So it has a special meaning here. This is called forward difference or advancing difference operator. We can call it as forward difference operator or advancing difference operator, as I have told you a while ago. And then we have the property. We have delta to the n times delta to the n f sub k. Okay, that is simply, so we add the two n plus n, so delta to the power of n plus n f sub k. So that's a property of the operator. Okay, it follows laws of exponents. So another property of the operator, if we are to determine the first differences of two functions that are added or subtracted, okay, we can simply write it as considering the first term. Okay, we have a, which is a constant, then we write delta f sub k plus or minus b, a constant, then we write delta g sub k. So this is a property of the operator. Okay, if we are to add or subtract to two functions f and g, okay, we are to add or subtract two functions f and g, and we are to get the first differences, okay, of the sum of the two functions or the difference of the two functions f and g. So this is followed, no? This property is followed such that a and b are constants. Okay, so we have here relationship between divided differences and differences of the function f for x values equally spaced in a table of data. So this is the derivation of the formula. Okay, so this is divided differences, right? This is divided differences. Now we will express divided differences in terms of differences of a function. Okay, Divided differences of a function can be expressed in terms of differences of a function. Okay? So in here, f of xo, x1, that is f of xo minus f of x1 all over xo minus x1. This is my discussion a while ago. And since the table, since all values of x are equal space in a table of data, we can able to rewrite f of x sub o, we write f sub o, f of x sub 1, we write f sub 1, all over xo minus x1. Then we can able to factor out the negative sign. So inside the parentheses, the sign of f1 will be positive, okay, minus f1, so that's negative, it becomes now positive f1. The sign of fo here is positive, so when we factor out the negative sign, it becomes negative, okay, all over negative x1 minus xo, similar to what we did in the numerator. We factor out negative sign, so x sub o minus x sub 1 becomes now negative quantity x sub 1 minus x sub o. And then what is f1 minus fo? That is simply delta fo, right? So that is simply delta fo. Recall, no? That delta fk, that is f sub k plus 1 minus f sub k. Okay? So therefore, if k is 0, that is f sub 1 minus f sub o if k is 0. That's why f1 minus fo is delta fo. Okay? x1 minus x sub o is what? x1 minus x sub o is h. So negative, negative, cancel, right? Negative over negative is positive. That's why, how about this x1 minus xo? That is simply h, right? Recall, no? That h is equals to x sub k plus 1 minus x sub k. If k is 0, x sub 1 minus x sub 0. So x sub 1 minus x sub 0 is simply h. Now, in my previous discussion, I have introduced this. No? So h. So that's the formula now. Okay? So f of xo, x1, divide the differences of f is equals to first differences of f over h. Okay? Considering second differences of f. So the formula, you know this, I have discussed this in my previous, in the previous slide, no? So f of xo x1, f of xo x1 is simply delta fo over h. So delta fo over h. F of x1 x2, so palitan lang natin kung may pattern kasi eh. Kung ito ay 0, 1, 0 yon. Kung ito ay 1, 2, 1 ito. So, dahil ito ay 1, 2, delta F1 over H. Tapos, XO minus X2. Ang X2 ay XO plus 2H, right? Recall natin. Okay. That X sub K is equals to X sub O plus KH. Okay. So, kung ganon, if K is 2, that is X sub O plus 2H. X sub 2 is X sub O plus 2H. Okay? So, and then we simplify. Negative 2h na lang yon. Factor out natin yung negative sign. Magiging delta f1 over h minus delta f2 over h. And then, using algebra para ma-simplify itong complex fraction, naging ganito ngayon siya. Okay? Using algebra. No? So, step by step natin. Sige. So, negative, negative, positive. So, makakancel na yon, no? Negative, negative. So, ito na lang matitira. Delta F1 minus delta FO over, common naman yung H. So, pag-isahin ko na lang. Pwedeng pag-isahin. Over 2H. So, 2H na lang nun. So, yung H tsaka 2H, magko-combine. So, H times 2H is 2H squared. Okay? So, nag-apply ako ng laws of fraction. Okay? That is A over B times the reciprocal D over C. Okay? So, sabihin nito, 2H over 1 yan. So, delta F1 minus delta FO over H times reciprocal 1 over 2H. So, kaya H times 2H, 2H squared. Okay? So, that's it. So, we have now this one. And then, paano nakuha yung delta squared FO? Recall ulit natin, no? Recall natin ulit that delta squared F sub k equals to delta F k plus 1 minus delta F sub k. Ayun ang formula. If k is 0, delta squared F sub 0, k is 0, delta F1 minus k is 0, delta F0. Ayan. Delta F1 minus delta F sub 0. That's it. Kaya nakuha yan. So in general, so this is the formula. Okay. So let's say halimbawa, ito kasi second order. Kung nth order divided differences. So yung nth order divided differences, okay, can be obtained using the formula nth differences of f at k equals 0 all over n factorial multiplied by h to the power of n. Okay? So, yun ang formula natin. So, yung interval to the power of n. Okay? So, yun. Likewise, in general, no? So, yung 0 na yan, pwedeng palitan ng k. So, magiging k plus 1, k plus n. So, yung 0 na to, mapapalitan ng k. Okay? Ganun siya. Delta nth differences of f over n factorial times h to the power of n. Such that k is an integer. No? Ang k natin is any integer. So, ito yung okay, yan. So, let's answer an example. Construct the forward difference table of the given function. So, ito yung ating table. So, we are to construct the forward difference table of the given function. So, ito yung solution. Ito yung table natin. So, tignan muna natin, analyze muna natin. Sabi niya forward difference table. So, forward difference table or advancing difference table. So, therefore, meron ditong delta. Delta F. No? So, merong involved na delta FK. Delta squared FK. At anong property ng table? Dapat, no? Lahat ng values ng x equal space. No? Equal space. 4.5, that is 0.5. Pa? 0.5. Sorry. Check natin. Pagka hindi sila equal space, we cannot apply. We cannot obtain the forward difference table because it's not applicable dahil hindi sila equal space. Yung mga values ng x. Ayan, equal space siya. Therefore, we can apply, we can able to determine the forward difference table because it satisfies this condition. No? That the difference between two successive values of x, or should I say the two consecutive values of x, are uniform. No? So the difference between two consecutive values of x is uniform. No? Okay, so we have here, this is 4, this is x of 0, 4.5, x of 1. Okay, take note. So we arrange them from lowest to highest, and arranging them from lowest to highest, since naka-arrange naman kanina, so no problem. So ganito rin ang pattern niya, xo hanggang x of 4. Okay, and then ito naman, f of xo, f of x1, f of x2, f of x3, f of x4. Dahil na-satisfy yung condition na uniform interval, therefore, pwede nating gawin na lang f sub o, gawin natin tong f sub k, gawin natin f sub 1, f sub 2, f sub 3, f sub 4. Okay? So, that's it. So, eto ngayon. So, madali lang, no? So, ito yung column para sa functional values. Okay? Ito yung column para sa first differences of f. First differences of f. Ito yung mga first differences of f. Ito yung mga second differences of f. Ito yung mga third differences of f. Okay? And ang tawag ngayon dyan ay difference, forward difference table or advancing difference table. Okay? So, paano ba makukuha yung sagot dyan? So, we have here delta FO. So, recall natin. Delta FK is F, K plus 1, minus F sub K. So, in that case, ito yung for K equals 0, no? For K equals 0, that is F1 minus F2. So, therefore, F1 minus FO, yun na yun. Okay? Ito, paano nakuha yan? Delta squared F sub K, formula. Delta Fk plus 1 minus delta F sub K. So, if K is 1, If k is 1, delta squared f1, delta f sub 2 minus delta f sub 1. So, delta f sub 2 minus delta f sub 1. Yun na yan. Okay? And then last, itong delta cube fo. So, delta cube f sub k. Okay? So, paano yung ano natin? Recall natin. Recall natin. We have delta n f sub k, that is equals to delta n minus 1 f sub k plus 1 minus delta n minus 1 f sub k. No? So, yun ang formula. So, therefore, delta squared f sub k plus 1 minus delta squared f sub k. Okay? So, for k equals 0, delta cube f sub 0, delta squared f sub 1 minus delta squared f sub 0. Delta squared f sub 1, ito, minus delta squared f sub 0, ito. Para makuha yung delta cube f sub 0. So, that's it. No? So, na-discuss ko na yan. Okay, so apply lang natin. So, how did we arrive with this value? 1.65096 minus 1.5874. Okay? Ito naman, paano na tayo nag-arrive dito? So, that is, ano to? This is delta f sub 1, right? Kasi, magsisimula ka ng k0. So, k1. So, delta f sub 1. Ano naman ito? F sub 1. Ano naman to? F sub 2. So, delta f1 is simply f2 minus f1. Okay? So, magkukuha na natin nun ay 1.70998 minus 1.65096 is equals to 0.05902. Diba? It follows this formula. Fk plus 1 minus f sub k. So, if k is 1, ayan. Okay? So, we proceed. And then, ito, paano tayo nag-arrive dito? So, that is delta squared f. Ano to? Delta squared f sub 1. Kasi ito yung f sub 0. F sub 1. So, delta squared f sub 1, that is delta f sub 2 minus delta f sub 1. So, ito yung delta f sub 1. Ito yung delta f sub 2. Okay? That's it. And then, ito, paano tayo nag-arrive dito? So, this is delta cube. So, this is what? Delta squared f0, delta squared f1, delta squared f2. Ito, delta cube f sub 0, delta cube f sub 1. So, ano yung delta cube f sub 1? That is delta squared f sub 2 minus delta squared f sub 1. So, that's why dito, negative 0.00324 minus negative 0.00383, we'll get 0.00059. So yun, no? And then ito, okay, ito ay delta to the fourth f sub 0. So ano yung delta to the fourth f sub k? That is delta cube f sub k plus 1 minus delta cube f sub k. So kaya, kung yan ay 0, delta cube f sub 1 minus delta cube f sub 0, no? So in that case, this is delta cube f sub 0. This is delta cube f sub 1. So 0.0059 minus 0.00071. We get negative 0.00012. Okay? That's it. So as shown in the table above, find the first, second, third, and fourth divided differences of f. No? So take note, divided differences. Given yung mga differences. First differences, second differences, third differences, fourth differences. Wait lang. Okay. And fourth differences. Okay. Ayan. Ay, sorry. Ito, fourth differences. Okay. So, kunin daw natin yung first, second, third, and fourth divided differences ng function. Okay? Recall natin. Ano yung re-recall natin na formula? Ito. So, ito yung formula natin. So, ito yung nth order divided differences of f. Ito yung nth differences of f. Okay, n over n factorial e to the power of n. So, ibig sabihin niyan, given yung mga n differences ng f, hahanapin natin yung divided differences of f. Okay? So, hanapin natin yung mga divided differences of f. So, ito yung first order. First order divided differences of f is equals to, so, dahil first order, n is 1. Okay? N is 1. If n is 1, therefore, this is delta f sub 0. Okay? Kasi, ang k natin ay 0 ngayon. We let k equal to 0. For k equals to 0, no? For k equals to 0, this is f of x sub 0, x sub 1, hanggang umabot tayo ng x sub n. For k equals to 0, so this is delta sub n, f sub 0, n factorial e to the power of n. Okay? So, in this case, dahil ang n natin ay 1 dito. Ang n natin ay 1. So therefore, x0, x1 lang. Okay? x0, x1. So in this case, n natin ay 1, so delta fo lang siya. Then n is 1, 1 factorial, h to the power of 1. Or simply h. Kaya ganyan siya. Delta fo over 1 factorial times h. Okay? Para sa pagkuha ng uh, f of x1, x2, okay, another divided difference, no? So dito, ang k naman natin ay 1. Nagsimula siya sa 1. K is 1. So kung ganon, kung nagsimula siya sa 1, so x sub 1, x sub 2, okay, hanggang umabot ka ng k is 1, no? 1 plus n. Hanggang umabot ka ng 1 plus n. Okay? So, in that case, magiging delta to the power of n, f sub 1 siya ngayon. Okay? Kasi it follows yung k, yung k. F sub 1 over 1 factorial, sorry, n na. N is 2. Sorry, mamaya na yun. N factorial over h to the power of n. Ngayon, dito ay x sub 1, x sub 2. So hanggang x sub 2 lang siya. Delta f1, 1 factorial times h. No? So ano yung n natin ngayon? Ang n natin ngayon ay 1, no? Ang n natin ay 1 pa rin. Kasi first order, di ba? First order pa rin yan. Okay? First order pa rin. So, kung first order pa rin, n is 1. Ito, first order, n is 1. So, in this case, f of x1, x2, okay, delta, kasi first order yan, n is 1. Delta f1 over 1 factorial times h to the power of 1. Kaya ganyan siya. Okay? And then, ganito pa rin ang pattern. Okay, delta f1, delta f2 na ngayon. x3, x4, delta f3. Then, x0, x1, x2. No? So, ito yun, delta squared f0, 2 factorial h squared. So, tatlo na siya, no? So, kung tatlo na siya, we start with 0. F of x sub 0. So, k is 0, no? K is 0. So, k is 0, x sub 0, x sub 1, hanggang umabot ka ng x sub n. Then, delta to the power of n, f sub 0, kasi k is 0. Okay? Over n factorial h to the power of n. So, dahil kinonsider natin hanggang x2, x sub 0, x sub 1, x sub 2. So, this is delta. So, this is second order, diba? Kasi tatlo sila. Second order divided differences. So since this is second order divided differences, no, we have delta squared, no, delta squared f sub 0 2 factorial h squared. Okay, so ito siya. Okay, and then x1, x2, x3. So x1, x2, x3. So x1, x2, x3. So ano na siya, no? Ang k natin ay 1. So 1 plus n. 1 plus n. Ayan. Ang k natin ay 1. 1 plus n. Okay? So pag gaganon, ang k natin ay 1. Delta to the n, f to the f sub 1. Okay? N factorial, h to the power of n. So, kinonsider lang natin tatlo, x1, x2, x3. X sub 1, x sub 2, x sub 3. Okay? And then we have, so delta to the power of n. So what is n? Ano tong 3? 3 is equals to 1 plus n, right? Ito, 1 plus n siya, di ba? So, 3 minus 1 is equals to n. So, n is 2. So, delta squared f sub 1 over 2 factorial h to the power h squared. There. Okay? N is 2. So, I hope you get it, no? Ito, x2, x3, x4. Okay? X2, x3, x4. So, x2, x3, hanggang, so k is 2, no? This is your k. Kaya, ganyan siya, no? So, k is 2. So, x2, x3, 2 plus n. No? 2 plus n. Okay? Delta squared f sub. Ang k natin ay 2. Ayan, k is 2. Okay? Ngayon, if k is 2, what is n? So, ito yung 4. Equal yan sa 2 plus n. So, 4 minus 2 is equals to n. Still, n is 2. No? Kaya, delta squared, 2 factorial, 8 squared. Okay? So, that's it. So, ito, third naman. Okay? Ganyan lang ang pattern, no? Okay? 0, 1, 2, 3, 1, 2, 3, 4. Okay? 0, 1, 2, 3, 4. No? Ayan, no? So, ito yung mga sagot. Kasi, kung mapapansin nyo, pakita ko lang yung ating yung previous. Kung mapapansin nyo, meron tayo dito, yan, delta f0, delta f1, hanggang delta to the fourth f sub 0. So, lahat yan. Kung meron kang delta f sub 0, okay, ano yung f of x sub 0, x sub 1? O kung meron kang delta f sub 1, ano yung f sub x sub 1, x sub 2? Okay? Kasi find the first, second, third, and fourth divided differences. Ang dami nun. So, ito yung mga first divided differences. Pati ito, f x2, x3, and so forth. No? Kaya, yun yung sinod natin. Okay? Kaya ito yung mga sinod natin. Meron kang delta f o f of xo x1. Ano, meron kang delta f1. Ano yung f of x1, x2? Meron kang delta f2. Ano yung f of x2, x3, and so forth. Okay? So, that's it. So, ito yung mga sagot. Okay? Ano yung age natin? Ang age natin ay, ano yung age value natin? 0.5, right? Is it 0.5? Tama, 0.5. Right? 0.5. 5 minus 4.5 is 0.5. 0.5. 0.5. Okay? Okay. Okay na yan. So, we can now proceed. No? Differences of a function using the central difference operator. Okay. This is the Greek letter delta, lowercase delta. No? So, this is also delta, which is a lowercase letter. So, this is also delta. No? An uppercase. No? An uppercase letter. Okay? Now, we have this operator, which is what we call as the central difference operator, concerning differences of a function. Alright, so we have here the central difference table. So in my previous discussion, I have introduced to you the forward or advancing difference table. So this time, we're going to talk about the central difference table. So this is the central difference table, as you know, as you can see. So we have the variable x, okay, the arguments. So these are the arguments, okay, x sub 0, x sub 1, x sub 2, x sub 3, and so forth. Then we have also the functional values, f sub k. So we have f sub 0, f sub 1, f sub 2, f sub 3, and so forth. No? Now, in the third column, okay, so this is the first differences of a function. No? The first differences of a function. So, in terms of the central difference, no? So we have the first central difference of a function. No? So this is delta f sub k plus 1/2. Okay? So this is the first central difference of a function. So these are the first central differences of a function. Okay. Then we have here the second central difference of a function. So these are now the second central differences of a function. Okay. Then we have the third central differences of a function. Okay. So this will continue now until we reach delta to the power of n f sub k plus n over 2. Okay. So delta to the power of n f sub k plus n over 2. Okay, this is just an alternative. So before, I have introduced to you the forward difference table. This is delta f sub k. This is delta squared f sub k. This is delta cube f sub k. In short, delta f sub k is simply equal to delta f sub k plus 1 half. Delta squared f sub k is equals to lowercase delta squared f sub k plus 1. Uppercase delta cube f sub k is equals to lowercase delta cube f sub k plus 3 halves. Okay? So they are equal, no? So, so we now proceed. So as you notice here, we have the interval h, the tabular interval h. Okay? It is uniform, no? This is uniform. Okay? So h is constant. So this is obtained by subtracting the preceding value of x to the successive value of x, no? Or should I say the preceding argument? No, we subtract the preceding argument from the successive argument. Okay, that is x sub 1 minus x sub o. Okay, in this case, this is the preceding argument and this is the successive argument. Okay, so x sub k here is the preceding argument and x sub k plus 1 is the successive argument. No? So, you know this, I have already discussed this in detail in my previous discussion. Okay, and then we have here x sub k, no? X sub k, so we can, so actually this, we can able to write this as x sub k h plus x sub k equals x sub k plus 1. Okay, and then so in here x sub k equals to x sub 0 plus kh, no? So I already introduced this before. This is just the same as the analysis for the forward difference table, no? Okay, so for instance, if I have, if k is, if k is 1, this is x sub 1, right? So that is x sub 1 is x sub 0 plus 1h, or simply h. Okay, if k is 2, if k is 2, that is x sub 2 xo plus 2h, no? This is x sub 2 and we know that This is age and this is age, the tabular interval. So we have x sub 0 plus h, that is x sub 0 plus 2h will give us x sub 2. Okay? And then we have delta f sub k plus 1 half. Okay, so we have here the first central differences of a function. Okay, so delta f sub k plus 1 half can be obtained by subtracting the preceding functional value from the successive functional value. Okay, so we have f sub k plus 1 minus f sub k. So we can obtain the first central differences of the function. Okay, and then in this case, we have the second central differences of a function. Okay, in obtaining the second central differences of a function, this is delta squared f sub k plus 1. Okay, so how do we determine this? So we simply subtract the preceding first differences of a function from the successive first differences of a function. Okay, so that's the pattern. So delta f sub k plus 3 halves minus delta f sub k plus 1 half. Okay, so let me show you, let me illustrate this in detail so that you can understand. Let's say we consider this. Okay, so if k is 0, for example, for k equals to 0, so that is delta f sub 1 half. That is simply f k0 f sub 1 minus f sub 0. So in this case, to determine the function, uh, the value of the first differences of this function, no, for k equals 0, so we have f sub 1 minus f sub o. Okay, f sub 1 minus f sub o. Okay, so that's the procedure and how to do it. No? Another example, if we consider for k equals, let's say k equals 2. So that is delta f. If k is 2, that is 2 plus 1 half. That is 5 over 2. 2 plus 1 half is 5 over 2. So that is f sub k is 2. So 2 plus 1 is 3. Then k is 2, f sub 2. So in other words, no, we can able to determine the value of this delta f sub 5 over 2 by subtracting f sub 2 from f sub 3. Okay, so we simply subtract f sub 2 from f sub 3. So that is f sub 3 minus f sub 2. Okay, so that's the procedure. Similar to my previous discussion on forward difference table, no? So now, how about this? Okay, let's say for k equals 1. For k equals 1, this is delta squared f sub 2. 1 plus 3 halves is 5 halves. No? Delta f sub 5 over 2. And 1 plus 1 half is 3 halves. Delta f sub 3 halves. So in this case, where we are interested in finding the value of, excuse me, na ano, so we are interested in finding the value of delta squared f sub 2, no? So to determine that, so we subtract delta f sub 5 over 2, or should I say we subtract delta f sub 3 over 2 from delta f sub 5 over 2. That is delta f sub 5 over 2 minus delta f sub 3 over 2. Okay? So we proceed. So always remember, in obtaining this um, these notations, no, delta f sub k plus 1 half, delta squared f sub k plus 1, delta cube f k plus 3 halves. It follows this pattern. Okay, it follows this formula, or this notation is delta sub n f k plus n over 2. For example, I'm interested in finding the first central differences of the function. Therefore, n is 1. So this will become delta f k plus 1 half. So this is obtained. Okay. Suppose I'm interested in finding the third central differences of the function. So n is 3. So delta cube. So I have delta cube f k plus 3 over 2. So that is k plus 3 over 2. Okay? So that's it. So we now proceed. And then we are interested in finding the nth differences of the function. So see, this is the formula. No. So delta sub delta to the power of n f sub k plus n over 2 is equals to delta to the power of n minus 1 f sub k n plus n over 2 plus 1 half minus delta to the n minus 1 f sub k plus n over 2 minus 1 half. Okay? For example, um, let's try delta for n equals, or for k equals n muna, for n equals 7. For n equals 7, so that is delta to the power of 7 f k plus 7 over 2 equals to delta n minus 1 is 6. 7 minus 1 is 6. F k plus, now we have n is 7, right? So that is 7 over 2. So 7 over 2 plus 1 half a minus delta to the power of 6 f k plus n is 7 minus 1 half. So simplifying that, we have, so we have delta to the power of 6 f k plus, so 7 over 2 plus 1 over 2, that is 8 over 2, that is 4. K plus 4 minus delta to this power of 6 f sub k, 7 over 2 minus 1 over 2 is 6 over 2, that is 3. So k plus 3. There. No? So this is now the formula. No? If for instance k is 1, if k is 1, so that is delta set to the power of 7. So 1 plus 7 over 2, that is 9 over 2. Okay? So delta to the 6, k is 1, so that is f5, f sub 5, delta to the power of 6f, 1 plus 3 is 4. That's it. So that's the formula. No? Okay? So that's it. No? So we now proceed. So we have here differences of a function using the central difference operator delta. So by definition, okay, delta f sub k plus 1 half is simply equal to k f sub k plus 1 minus f sub k. Okay, so this is the formula in finding the first central differences of the function. Okay, we subtract the preceding functional value from the successive functional value. Okay, and then this is true for every integer k, whether k is negative or 0 or positive integer. No? So note that, alright, remember this, no? So lowercase delta f sub k plus 1 half is equals to uppercase delta f sub k. This is the forward difference operator. This is the central difference operator. Okay? When we are to express delta f sub k plus 1 half in terms of the forward difference operator, this is the notation, delta f sub k. Okay? So that is delta f sub k. So in that case, that is f sub k is subtracted from f sub k plus 1. Okay? So f sub k plus 1 minus f sub k in order to determine the first differences of the function. Okay? And then if k becomes k plus 1, what will happen if k becomes k plus 1? So k becomes k plus 1, so delta f, so k becomes k plus 1 plus 1 half. So this will be simplified, that becomes k plus 3 halves. Okay? And then this becomes k plus 1. Then, okay, that becomes, and this becomes, so that is f k plus 1 plus 1. No? K becomes k plus 1, then another plus 1, so we have k plus 2. So in here, k becomes k plus 1. Okay? So that will be the corresponding conversion. No? Now, let's answer a problem regarding this topic. We are to construct the central difference table of the given function. Okay? So as you notice, no, we have this table and we are to construct, we are to determine the central difference table. Okay? So the first thing to do is we are to determine uh, whether or not we can able to construct the the forward the central difference table. No. So what are the things to consider here? First thing to do is you have to, this should be arranged in descending order, or should I say ascending order, from lowest to highest. 4, 4.5, 5, 5.56. Okay. Then we assign the values x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. Okay. Next step, we have to determine whether the tabular interval is constant. No? So, what's the tabular interval value here? 0.5. How about here? 0.5 also. This one, same. And this one, okay. Okay, also the same. Okay, therefore, we can now construct, we can now proceed with the next step. No? It satisfies the condition that the tabular interval is constant. Okay, we can now construct the central difference table. So doing that, no, so this is the template in constructing the difference table. No? So we have here x sub k, f sub k, delta f sub k plus 1 half, delta squared f k plus 1, delta cube f k plus 3 halves. So, what's the next? Halimbawa, marami pa yan. Anong next nito? Delta to the fourth, f sub, o paano ko malalaman? Recall natin. So, that is delta to the power of n, f, k plus n over 2. Okay? So, k plus, ano ang n? 4. 4 over 2. So, k plus 2. Okay? And so forth. It follows this, no? This notation. You just substitute, no? The value of n, no? So, we are to continue now, no? So in this case, recall that delta f sub k plus 1 half equals to f sub k plus 1 minus f sub k. Delta squared f k plus 1 is equals to delta f sub k plus 3 halves minus delta f sub k plus 1 half. No? So this was, I already introduced this previously. So we're just recalling. No? Then delta to the power of n, f sub k plus n over 2 equals to delta to the power of n minus 1, f sub k plus n over 2 plus 1 half minus delta to the power of n minus 1, f sub k plus n over 2 minus 1 half. No? So we can proceed now. Okay. Now in this case, this is how did we get 0.06356? No? We start with this is for k equals to 0. No? This is for k equals to 0. No? So in that case, it starts with 0. So that is so this is now delta f sub 1 half. Okay? Delta f sub 1 half. And recall, no? Recall that delta f k plus 1 half is equal to f sub 2 minus f sub 1, right? F sub 2 minus f sub 1. So that is, this is f sub 2, and this is, or should I say, sorry, f sub 1 minus f sub 0. Okay, for k equals to for k equals to 1, for k equals to 0, I mean, for k equals to 0, f sub 1 minus f sub 0, because f sub k plus 1 half, that is f sub k plus 1 minus f sub k. No? So this is the preceding value subtracted from the successive value of f. So if k is 0, that is f sub 1 half, k is 0, that is 1, k 0 0. Okay, f sub 0. So we get f sub 1 minus f sub 0. So this is f sub 0. So we just subtract. So 1.65096 minus 1.5874, we get 0.06356. Okay. So another, let's try this. How did we get this? This is what? Delta F. So what is K? K0, K1, K2, K equals to 3. So 3. So it's 3. 3 plus 1 half. So that is, what is 3 plus 1 half? 3 plus 1 half is 7 over 2. So this is 7 over 2. Okay. And so this is f sub 0, f sub 1. This is f sub 2. This is f sub 3. And this is f sub 4. Okay. So in that case, for k equals, so k value here is 3, right? 0, 1, 2, 3. Okay. So in that case, delta f, so we have 3 plus 1 half, that is 7 over 2. Okay. Equals to f, 3 plus 1 is 4, then 3. F sub 4 minus f sub 3 equals to this value, delta f sub 7 over 2. No? So equal to delta f sub 7 over 2. So 0.05195 is the answer. Okay? Alright, so we continue. So how about this one? How did we arrive at negative 0.00000383? Alright, so this is delta squared f sub k plus 1. What's the formula for delta squared f sub k plus 1? Okay, delta squared f sub k plus 1 is equals to, so delta f, okay, delta f, k plus 1 half. So k plus 1 half, ano yung formula? So recall natin. Ito, delta f, k plus 3 halves. Okay. Kasi ito yung general eh. Pagka alam natin to, madiderive na ito, madiderive na rin yan. Okay? So, I'm encouraging you to memorize this para kahit hindi natin memorize ito ay basta alam natin to, madiderive natin. Okay? So, in that case, ito. So, halimbawa, hindi ko alam to. Pero alam ko yung formula na delta to the n power f sub k plus n over 2. That is equals to delta to the power of n minus 1 f sub k plus n over 2 plus 1 half k plus n over 2 plus 1 half minus delta n minus 1 f k plus n over 2 minus 1 half. Okay, am I correct? Let me see. There. K plus n over 2. So, madali lang naman i-memorize. K plus n over 2. Ito. Tapos, nagbabago lang dito. May plus 1 half doon. Merong minus 1 half doon. Ito, mababawasan ng isa. N minus 1, n minus 1. Ganun lang, no? So, that's the pattern. Okay? So, in that case, ayan. For n equals to, kasi, ano yun second differences. So, we have delta squared f k plus n is 2. So, that is 2 over 2 is 1. So, n is 2. 2 minus 1 is 1. So, f k plus. So, n is 2. This is 2 over 2 plus 1 half 3 over 2. K plus 3 over 2 minus delta f k 3 over n is 2, so 2 over 2 minus 1 over 2, that is 1 over 2, k plus 1 half. Okay, there. And then, so this is now my formula, right? This is now my formula. Let us verify whether this is exactly the same in my previous slide. K plus 3 over 2, k plus 1 half. K plus 3 over 2, k plus 1 half. There you go. It's correct. No? So we proceed. So this is delta squared f for k equals 0 for k equals 1. So this is k equals 1. Delta squared f sub 1 plus 1 is 2. Okay? Delta squared f sub 2. So that is my concern for k equals 1. Okay? So for k equals 1, so that is delta squared f 1 plus 1 is 2. K is 1. 1 plus 3 halves, that is 5 halves. 1 plus 1 half, that is 3 halves. Okay, so let's see. For k equals 0, okay, that is delta f 1 half. For k equals 1, delta f 1 plus 1 half is 3 halves. Then for k equals 2, 2 plus 1 half, 5 halves. There, okay? So delta f 5 halves minus delta f 3 halves. Okay, so you just subtract, then you'll obtain delta squared f sub 2. Okay, next. So let's proceed. How did we arrive with this one? 0.0059. So let us solve. How did we arrive at 0.0059? So what is this? So this is k equals, for k equals to, for k equals to 1. Okay? Kasi k equals to 0 to, k equals to 1 ito. Okay, for k equals to 1, so this is delta cube f sub 1 plus 3 halves is 5 halves. Okay, so n is 3. For n equals to 3, so delta cube f k plus 3 over 2, delta squared f k plus n is 3, 3 over 2 plus 1 half, that is 4 over 2 or 2. Delta squared f k plus n is 3, 3 over 2 minus 1 over 2, that is 2 over 2 or 1. There, this is now the formula. Okay, and for k equals to 1, so we have delta cube f 1 plus 3 halves, that is 5 halves, delta squared f 1 plus 2 is 3, 1 plus 1 is 2. There you go. So let's determine. So this is delta squared f sub 1 for k equals 0, delta squared f sub 2 for k equals 1, delta squared f sub 3 for k equals 2. So delta squared f sub 3 minus delta squared f sub 2. So you just subtract this, you just subtract delta squared f sub 2 from delta squared f sub 3 to obtain delta cube f sub 5 over 2. Okay, so that's it. Now let's proceed here. Delta to the fourth fk plus 2. So did we arrive with this? So this is delta to the fourth f sub k0. So that is delta to the fourth f sub 2. So if n is 4, 4 over 2 is 2. So this will become 3. K is unknown. Okay, n is 4. 4 over 2 plus 1 over 2, 5 over 2. Delta cube f k k plus 4 over 2 minus 1 over 2, that is 3 over 2. Okay, and then we have, so for n equals 4. No, this is for n equals to 4. For n, for k equals, for k equals 0. Okay, for k equals to 0, because this value, no, negative 0.00100012 has a value of k equals 0. No, so in that case we have delta to the fourth f 0 plus 2 is 2, delta cube f k0, so 5 over 2, k0 3 over 2. Okay, so that's it. So this is delta cube f5 over 2, this is delta cube f for k equals 0, 3 over 2. There. Delta cube f5 over 2 minus delta cube f3 over 2. So that's it. So let's now proceed with this topic, the shift operator E. So we have this operator E, when we introduce it to a function, no? So in here we have e to the 1 or e. This is called the first shift, no? The first shift of the function. The first shift of the functional value, okay? The first shift of the functional value is simply equal to, so interpretation ito, the first shift of f's, the first shift of f of x sub k, no? The first shift of the functional value, no? F sub k or f of x sub k is just the same, no? They are just the same. So in here, when we introduce e, what happens? Okay, so when we introduce e, that is simply equal to f of x sub k plus h, meaning the argument, okay, is increased by h, which is the tabular interval. So it is increased by h. So it is shifted, no? Shifted by h, no? So that is the interpretation, okay? So the purpose of e is to shift the argument, no, by one tabular interval, no? It is increased by one tabular interval. The argument is increased by one tabular interval. And in this case, recall that h is equals to x sub k plus 1 minus x sub k. Okay? So, in that case, so halimbawa, x sub 0, x sub 1, x sub 2. No? So, ito yung ating x sub k plus 1. Ito yung ating x sub k. Okay? So, kung yun yung x sub k natin, so ang h natin, so yan yung h. H is x sub k plus 1 minus x sub k. I-rewrite natin, so that is simply x sub k plus h is equals to x sub k plus 1. Ayan. X sub k plus h is equals to x sub k plus 1. Kaya, ito yon. X sub k plus h is equals to x sub k plus 1. That's it. Recall also that f of x sub k equals to f sub k. If k is converted to k plus 1, so what happens is that this becomes f of xk plus 1. That is f sub k plus 1. That's why x sub k plus 1 becomes, okay, x sub k plus 1, no, the function f of x sub k plus 1 becomes f sub k plus 1. So that's the reason, no? So this is the conversion, no? F of x sub k to f sub k, no? So we proceed. So the operator E increases the argument of a function by one tabular interval. Okay, so that's the purpose of E, to increase the argument of a function by one tabular interval. Pag sinabi kong argument, yun yung mga x values, no? So, and then we have So by definition, no, ito yon. So this is true for every integer k. Okay? And note that the first shift of the function k is simply equal to f sub k plus 1. Dahil dito sa derivation na to. Ito yung derivation eh. Kaya na-conclude na yung ef sub k ay equal sa f sub k plus 1. No? That's the reason. Kaya naging equal. Kaya naging ganyan. Okay? Dahil dumaan sa derivation. Okay? So, remember the formula now. Okay? ef sub k equals to f sub k plus 1. How about the second shift of the function? Okay, the second shift of the function is squared f sub k. So, ibig sabihin yan, we can separate, no? Ibig sabihin yan, the first shift of the first shift of the function. First shift ng first shift, no? So, ibig sabihin yan, second shift, no? So, isi-shift mo yung first shift. So, second shift. So, ef sub k. And ano yung ef sub k? That is f sub k plus 1, di ba? By definition, ito yun. So, ito siya na. So, e of f sub k plus 1, okay, that is, ang interpretation niyan, f sub k plus 1 ay f of x sub k plus 1 na na-derive ko kanina, no? So, yun yun. And then, yung f of x sub k plus 1 ay equal din siya dito. Okay? X sub k plus 1 plus h. Ito. X sub k plus 1 is equals to, ito yon, x sub k plus 1 plus h. Sorry. ef e ef of x sub k plus 1 is equals to f of x sub k plus 1 plus h. Nawala na yung e. Nawala na yung e. Okay? Para maalis yung e, dagdagan mo ng h dito. Plus h. Okay? Kasi recall nyo, no, that ef sub k, ef of x sub k, the first shift of the function, okay, para mawala yung e, lagyan mo ng h, mag-add ka ng h sa argument. O, nawala na yung e. So, nawala na yung e dito kasi naglagay tayo ng h dito sa argument. Okay? So, that's it. No? O, tapos, paano siya naging ganito? X sub k plus 2. Paano siya naging x sub k plus 2? Paano siya naging x sub k plus 2? Or recall natin that h is equals to x sub k plus 1 minus x sub k, right? Or simply, x sub k plus h equals to x sub k plus 1. I-shift natin. Pag yung k naging k plus 1, anong mangyayari? Yung k naging k plus 1. So, x sub k plus 1, so itong k na to, k plus 1 na yun, plus h. So, ang k na to ay k plus 1. Tapos, another plus 1. So, we have x sub k plus 1 plus h, x sub k plus 2. No? Ayan. X sub k plus 2 siya. Kaya na-derive na ganun. So, x sub k plus 1 plus h is simply x sub k plus 2. O, tapos, naging f sub k plus 2. Dahil dito. f of x sub k is simply f sub k. Pag yung k naging k plus 2, f of x sub k plus 2 equals to f of f sub k plus 2. Okay? So, ganun siya. So, ano napansin natin? So, ito yung ito ngayon yung importante nalaman natin. E squared f sub k is simply f k plus 2. F sub k plus 2. So, nawala yung e squared na dagdagan ng 2 dito. Naging k plus 2. Kanina, nawala yung e. Nadagdagan ng plus 1 dun sa k. Nakita niyo yung pattern? So, nagkaroon siya ng pattern. No? Sabihin niyan, kung ito ay r, e to the r, f sub k, magiging f, k plus r. Okay? So, using inductive reasoning, we can able to conclude that the arc shift of the function is equals to f sub k plus r. No? So, that's it. Take note that, wait lang, in general, ayan, ito yung sinabi ko kanina, e to the r, f sub k is equals to f sub k plus r. Yung arc shift ng function ay equal sa f sub k plus r. No? So, sabihin nito, f sub k plus r, that is f of x sub k plus rh. Ganyan ang ibig sabihin niyan. F of x sub k plus rh. No? Okay. So, we continue. So, such that r is an element of the set of real numbers. So, yung r na yan ay pwedeng decimal, pwedeng integer, no? So, basta yung r ay isang real number. Okay, another property of the shift operator. Okay, the shift operator is, if we are to get the arc shift of the s shift of the function, no? Arc shift ng s shift. Okay? So, simply, using laws of exponents, pag-add natin yung exponent ng e dito na r, tsaka yung exponent ng e dito na s, that is e to the r plus s. Okay? So, r plus s shift of f sub k. Yun ang interpretation. Such that r is an element of the set of real numbers. And s is also an element of the set of real numbers. Another property, okay? So, meron siyang linearity property. Pag sinabi ko ang linearity property, kung mag-add ako or magsasubtract ng dalawang functions, simply, isi-shift ko yung unang function followed by yung pangalawang function. Add or subtract nun, no? So, in this case, a and b are constants. We have the two functional values, f sub k and g sub k, no? So, simply, so we have a, e, f sub k, no? So, introduce lang natin, no? Introduce lang natin. Then E, B, G sub K. No? So, B, E, G sub K. So, kumbaga, i-distribute lang natin. Okay? Okay. And then, such that A and B are constants. So, in here, we have relationship between the operators E and delta. No? So, anong kaugnayan ng shift operator dito sa advancing difference operator? No? Or forward difference operator. So, since EF sub k equals to F sub k plus 1, no? And delta F sub k equals to F sub k plus 1 minus F sub k, then, anong mangyayari? So, ang palitan natin itong fk plus 1 ng ef sub k. No? So, ito. Ito, palitan natin ito. Okay? So, dito napunta ngayon dahil lang fk plus 1 ay equal dito sa ef sub k. ef sub k minus f sub k. So, pwedeng i-factor out yung f sub k. So, we have e minus 1 f sub k. Okay? So, therefore, meron kang delta f sub k, e minus 1, f sub k. So, pwedeng alisin yung f sub k. So, matitira, delta equals e minus 1. So, ito yung relationship between the operators e and delta. Simply, delta is equal to e minus 1. So, that's the operational equivalence. And then we have relationship between the operators e and delta, lowercase delta. So we have ef sub k equals to f sub k plus 1. No? So we know this. And also we know this, that delta f sub k plus 1 half is equals to f sub k plus 1 minus f sub k. Then delta f sub k plus 1 half equals to, so palitan lang natin. So yung fk plus 1, palitan natin ng efk, naging napunta doon. So, tapos minus fk, minus f sub k. So equals to, so we can factor out f sub k. So we have e minus 1 f sub k. So recall natin that f sub k plus r, no? So yung plus r na yon, para mawala at maging k na lang, mag-introduce tayo ng shift operator. No? Yung arc shift, e to the r f sub k. Since delta f sub k plus 1 half equals to delta e 1 half f sub k, no? So, in this case, yung f sub, so alam natin to, delta f sub k plus 1 half is equals to delta e to the 1 half f sub k. Diba, ano to? Yung plus 1 half, para maalis yung plus 1 half, lagyan natin ng e. E to the 1 half f sub k para matira yung k dito. No? Para maalis yung plus 1 half, lagyan natin ng operator e. No? Beside f sub k. So, e to the 1 half f sub k. So, delta e to the 1 half f sub k. So, yun ang meron natin ngayon. No? And, delta f sub k plus 1 half ay equal dito sa e minus 1 f sub k. No? Kasi, we have derived Ito yan. The two are equal. So delta f sub k plus 1 half is equals to e minus 1 f sub k. No? So pagka ganon, alam natin yung dalawa na yan, then, no? Pareho naman delta fk plus 1 half. So we can equate the two, itong dalawa, no? Delta e1 half f sub k and e minus 1 f sub k. Then cancel natin yon. Okay? So which can be simplified as, so mamaya na natin i-cancel. So pwedeng mawala to by dividing both sides, no? By e to the 1 half. So delta e 1 half f sub k. So i-divide lang natin ng paano nagkaroon ng gano'n. So divide lang natin ng e to the 1 half on both sides of the equation. E minus 1 f sub k, okay, e to the 1 half. So cancel, okay. So delta f sub k. So ayun siya, no? Then e minus 1 over f sub k over e to the 1 half. So by loss of exponents, okay, ano yung e over e1 half? Ano yung e over e1 half? That is e 1 minus 1 half is 1 half. Diba? If I have a to the m over a to the n, recall natin, no? Using laws of exponents, that is a to the m minus n. Okay? Ma-minus lang natin yung exponent. Kaya nakuha yung e to the 1 half na yan. Tapos yung 1 over e to the 1 half. 1 over e to the 1 half, that is, okay? O, recall natin, kung meron akong 1 over a to the power of n, that is a to the negative n. No? Kaya e to the negative 1 half. Okay? Ayun. That's it, no? So, we can proceed. So, operational equivalence, pwede na nating alisin yung f sub k. So, delta is equals to e to the 1 half minus e to the negative 1 half. So, yun yung derivation. So, ito na yung formula natin. No? Delta equals to e to the 1 half minus e to the negative 1 half. So we proceed, no? So since f sub k plus r equals to e to the r f sub k, and delta fk plus 1 half, so ito naman relationship between the operators e, delta, and delta. So yung tatlo magkasama na sa isang equation. Okay? So since alam natin ito, at alam natin din ito, na equal yan, diniscuss ko kanina, no? So, then, para mawala yung 1 half dito, lagyan ko ng e. Okay, e to the 1 half. So, delta e 1 half, e to the 1 half f sub k. So, equal na siya ngayon dito. Okay, delta f sub k. So, and then, ito na yung operational equivalence natin. So, maka-cancel yung f sub k. Ayan, ito yung matitira. So, delta, uppercase delta equals to lowercase delta multiplied by e to the power of 1 half. No? So, that's the operational equivalence. So, delta equals delta e to the 1 half. No? So, in general, no? Okay. Tatlo yan. Delta is equals to e minus 1. Delta is equals to e to the 1 half minus e to the negative 1 half. Tapos delta equals to delta e to the 1 half. Ayan, tatlo, no? Check nga natin. So, delta equals to e minus 1, okay. So, delta equals to e to the 1 half minus e to the negative 1 half, okay. Then, ito yun. Delta equals to delta e to the 1 half. So, that's it. So, let's answer a problem regarding this topic. Prove that delta cube f sub k equals to delta cube f sub k plus 3 halves. Solution, recall natin ito. Delta equals delta e to the 1 half. So, anin natin? Raise natin sa power of 3 on both sides. Okay? So, kaya naging 3 halves. And then, maglagay tayo ng f sub k, magkabilang both sides, no? And then, so itong e to the power of 3 over 2 f sub k, magiging f sub k plus 3 halves siya, no? By formula, no? Recall natin that e to the r f sub k, that is f k plus r, no? E to the r f sub k, that is f k plus r, kaya k plus 3 halves. Okay? So, yun na yan. Delta cube f sub k, nakapakita natin, na-prove natin that delta cube f sub k equals to delta cube f sub k plus 3 halves. So, QED. Sabihin niyan, QED, Quod erat demonstradum. Quod erat demonstradum. Sabihin niyan, ano ibig sabihin nito? Ano yung QED, Quod erat demonstradum. What is to be shown? Ibig sabihin nito, interpreted as what is to be shown. Latin phrase yan, Latin phrase. What is to be shown. So, this is to be shown na equal yung dalawa. No? So, what is to be shown? So, second problem. Ito naman. Lowercase delta to the power of 6 f sub k plus 3 is equals to uppercase delta to the power of 6 f sub k. So, recall natin. So, pinaligtad lang natin kasi ang delta ay ang uppercase delta ay lowercase delta e to the 1 half. Right? So, e to the 1 half. So, divide natin or multiply natin both sides ng e to the negative 1 half. So, ito, pag ililipat doon sa kabila, okay, magiging negative 1 half. So, delta e to the negative 1 half equals to delta. So, ganun siya. Alright, so we can proceed. So, raise natin to the power of 6. So, negative 1 half times 6, that is negative 3. Kasi ito yung goal natin eh. Diba? I-raise natin sa power of 6. Then, mag-introduce na tayo ng functional value. So, pwede ako mag-introduce ng f sub k plus 3. No? Hindi lang f sub k. Kahit ano, k plus 1, k plus 2, k plus 3. Pwede. No? So, I can introduce f sub k plus 3. Okay? And then, mawawala ito. Paano mawawala? Okay? Add natin dito, plus negative 3. Para mawala yon, no? So, in that case, delta to the power of 6 f sub k plus 3 equals to delta to the power of 6 f sub k plus 3 minus 3. Okay? Or plus negative 3. So, in that case, magiging delta to the power of 6 f sub k plus 3 equals uppercase delta to the power of 6 f sub k. And that is to be shown. Okay? Na ano na natin, na-prove na natin. Theodera demonstratum. Okay? So that ends my discussion. Okay? I hope you get it. No? So, good day everyone.